I am a huge virtual reality enthusiast. I've been in the industry for a little bit more than 5 years now. 5 years ago, I tried an Oculus Rift prototype that was literally a piece of tech held together with duct tape. And ever since then, I did a lot of things to make virtual reality a little bit bigger, because I believe, and Nvidia believes, that virtual reality will become a pervasive technology in the future. So I started the biggest unofficial community for virtual reality on the net, together with a couple of other nerds on reddit.com, which is now the largest unofficial community for virtual reality. We also started a non-profit organization called EUVR.org to help push the envelope for the European VR ecosystem. So if you have any questions about this community background, please come back later and talk to me. I'm always glad to talk to other virtual reality enthusiasts. Right now, I'm heading up the VR business in Europe. That means that I'm trying to find and identify companies that we want to work with, because we believe, again, that it's going to be a pervasive technology. And what inspired us to think that way, and I think what also inspired me, was Star Trek. The holodeck from Star Trek, I think, is a concept that many, many people can understand. It's the way to totally immerse yourself in a different world. And the origin of Star Trek, the Star Trek's holodeck, is actually not the original series that you see here. It's an animated series from 1974, where the concept of the holodeck was first brought into the public sphere. And the holodeck essentially allows you to stand inside a virtual world that is completely simulated as the real world. And there's a couple of things that have to work for a holodeck to really function. It has to feel right, it has to sound right, it has to act right, and first of all, it has to look right. So how do you actually make this a thing? How can holodeck become a reality? This is the challenge that Nvidia is trying to solve by pushing the envelopes of computing power, not only on the graphics side, but in a couple of other ways as well that I'm going to mention in this talk. But first of all, let's take a look at when the holodeck was created. Back in the 70s, the holodeck was actually just a concept, because they were very far away from the actual vision of the holodeck. What you see here is Ivan Sutherland's Sword of Damocles. It's the first virtual reality, augmented reality headset ever. I'm going to show you this little video that shows how this looked back in the day. And everybody who's complaining about motion sickness with modern headsets, they should probably try this thing. These were the very early days. Essentially, the whole device was so heavy that it had to be held up by a couple of wire systems. That's why it was called the Sword of Damocles. And it was very early on. And computer graphics in the 70s were also super basic. What you just saw was essentially just a cube rendered in the real world. And if you take a look on the lower left right, can you recognize this guy? It's Indiana Jones. Oh, going back once, sorry for that. Got a couple of interferences here with the clicker that might happen a little bit more. So this guy's Indiana Jones, rendered in 28 pixels on the Atari 2600. How many people here have played with the Atari 2600? Oh, that's a relatively old crowd. Sorry, guys. What I want to say from this is there's a lot of people who still remember these archaic graphics, and it still felt kind of real. I mean, being able to interact with Indiana Jones, to steer him through these adventures, that's a pretty nice thing to do. And Indiana Jones doesn't want to leave. There we go. Simulating reality in the early 90s looked a little bit different. There were a couple of advancements. So if you look towards the lower right, you see the VR headsets of those times. Compared to even Sutherland's Sword of Damocles, it was a really big leap. They were lighter, they had better resolution, they had better tracking, but compared to today's devices, it's not even comparable. And the same thing counts for the content that was displayed on these virtual reality headsets. What you see up in the corner is something that I actually probably shouldn't be showing in Germany, but it's coming from a US presentation, so you get to see it. It's it's Wolfenstein 3D. It was one of the first 3D games invented by id Software. So what does it look like today? We are very much well advanced when it comes to rendering visuals in a way that are photorealistic. The guy you see here is actually not from the movie Star Wars, it's actually from the game Star Wars Battlefront 2. And if you take a look at the complete screenshot from that game, the way it has advanced in only 20 years is really astonishing. So we have these crazy lighting effects, we have shading, we have proper realistic environments that get rendered in a resolution that the people from 20 years ago would have only been dreaming of. So we got the content pretty much covered, and what we then have to do is we have to render this in a way that it's running at 90 frames per second on virtual reality headsets. And we're doing this on today's simulation engine, that is the Titan X that you see here. And the Titan X has 11 teraflops. And just to put this in perspective, the first supercomputer that reached 1 teraflop of processing power was the ASCI Red back in the late 90s. That was actually almost exactly 20 years ago. And it had 1.3 teraflops, and it used about half the size of this room to make that happen. Now you have about 9 to 10 times as much processing power on a very small chip that is available to everyone that can use a PC. And this is the king of the hill, so to speak. This is the Titan X. On the consumer side, there's nothing higher that you can get, but you still get an idea of how much we've advanced in the last 20 years. Because if we want to take this journey to the holodeck, where we have a completely visual system, a complete realistic system of rendering reality, where it's indistinguishable, we're going ever closer with ever bigger steps over the last couple of years and the next couple of years. And what you can do with this is rendering really photorealistic. What's super important in virtual reality is the fact that everything has to behave physically correct. If you have fire that doesn't behave just like it would in the real world, you're immediately going to lose this fragile sense of presence. Something will feel wrong. And we're making this possible with technologies like the GameWorks SDK. Take a close look at how the fire and the smoke interacts with the piece of metal that's hanging over it. I could watch this all day. I just love computer graphics, and seeing how much we've advanced in the last couple of years, people who played the original Wolfenstein, they would probably go totally crazy and think this is not a real thing that is rendered in real time. So everything you've just seen was rendered completely in real time on a Titan X. And then we're taking even a step further. One of our partners is working not only on getting the visual sense inside of the game, inside of virtual reality, but also other senses like haptics, for example. They are working on a haptic glove that allows you to interact with virtual objects just like real objects. And their next step, just gonna high five this guy. Next step is, that was close. Next step is to actually put people in a full haptic suit so that people can actually feel everything that's around them. In an ideal world, you'd feel heat, you'd feel cold, you'd feel bullets that hit you, probably not as realistic as in real life, but close to that. So that the sense of immersion, this suspension of disbelief that you need to get for proper presence is on point. And virtual worlds don't only need to feel right and look right, they also need to sound right. And we're allowing virtual reality developers to do exactly that by using our VRWorks Audio SDK. We're using a already invented system called Optics, which we use for ray tracing on the visual side, and use that ray tracing for audio as well. And this looks a little bit like this. Usually, what you do in a game, you have a direct sound coming from the sound source to the user. But that's not how sound works in the real life. Sound actually works a little bit more like this. Sound waves get reflected off of the environment. They get occluded by geometry that's in the environment, and reverb. And you also have reverb coming back from the sides of a big hall like this, for example. And then we also have, and then we're using now path-traced audio to make that happen. So essentially, we're ray tracing from the sound source through the room and give you a very good way to simulate audio. Because just as Michael Abrash, the chief scientist of Oculus, has said, a good audio is not an addition to good virtual reality, it's actually a multiplicator. And I fully agree with that sentence. Nope. One further, please. There we go. So we've got this covered. Virtual worlds have to look right, they have to feel right, they have to sound right, but they also need to act right. And one of the examples that I'm pulling up here is a game called Star Trek Bridge Crew. It's a ton of fun playing that together with games, so everyone who hasn't played it yet, download it. It's really, really good. It's a ton of fun. But what I want to go into a little bit more detail here is actually the speech-to-text implementation that they have. And this way, you can give voice commands to your artificial intelligence crew members, and that way you can give them commands in a very natural way. And IBM is making that possible through the Watson speech-to-text recognition, which is, again, also driven, and they're leveraging Nvidia GPUs to do that with the help of AI and deep learning, which is a great convergence of technologies to make a virtual reality experience better. And now you can also think of not only rendering virtual worlds, but actually capturing them in volume. This is an example that some of you might know from Windows HoloLens. It essentially allows you to do a holographic meeting.
And she's going to holoport into my space, and I'm going to interact with her wearing my HoloLens.
Hi, Bob, I miss you.
Hey, Lilia, I miss you too.
You coming home?
I'm coming home very soon. Let me get out of your way.
This is an example of real-world capture for, in this case, augmented reality, but virtual reality you also obviously want to capture real-world scenes to then be able to relive memories from your wedding, for example, or see a concert in virtual reality that really feels right. And we're making that possible by using a 360 stitching SDK that's also part of our VRWorks SDK that stitches in real time. So what we've shown at GTC in the US earlier this year is a camera system with 8 cameras in stereo that stitches real time on the GPU, allowing 360 content producers to make their workflows easier and get the production shot just as they want it. And we're using a couple of things in VRWorks to really simulate reality so that it is indistinguishable from the real world. So sight, we covered already. We covered physics and touch. We covered sound. And we're also allowing content producers to capture real environments and make them available in virtual reality. So the journey to Holodeck is a long way, but we're making giant leaps to actually make that happen. And one of the things we're doing now is called Nvidia Holodeck. It's our vision of simulating reality in a photorealistic way where you can collaboratively work with people from around the world to design products in a way that has never been possible before. But before I explain this, just check out this video. Interact with the car in a really photorealistic way and also realistic way when it comes to touch and haptics. But you can also go beyond this reality and, for example, explode all the 20,000 parts of this car in real time, rendered again in 90 frames per second. And this car has 50 million polygons that need to be rendered at the same time. So we've put a lot of work into making that happen for the future of collaborative design in virtual worlds. And even things like grabbing the steering wheel are physically correctly rendered. So your hands don't clip through the car. You actually have a feeling of this is a real object that is real solid. And of course, virtual reality is a ton of fun.
Behind the ears, buddy. You go fix that. That's good.
So we are really enabling the whole ecosystem. We're providing the hardware to drive these photorealistic simulations. We're building SDKs, software development kits that allow people to properly simulate audio and touch. And we're also doing applications like Nvidia's Holodeck or VR Funhouse that brings together all the goodies from the GameWorks SDK and make them available for virtual reality developers. But actually, we're just getting started. Nvidia is a company that's driven by the hunt for modern technology. So we're really spearheading the research and development in future fields of virtual reality. And one of them are light field displays or computational displays. And we've shown a display prototype that essentially renders multiple viewports in front of a micro lens array, and then the user perceives an image that actually allows you to focus on different layers of that scene, instead of being just instead of only being able to have one focus point, which is usually the case in current state virtual reality headsets. We're doing other things like foveated rendering, where we use eye tracking to see where a user is looking, and then rendering the rest of the image at lower resolution to make it possible to drive better effects, more particle physics, because we're saving overhead in rendering the actual scene because we're using less resolution in the peripheral part of the vision. So the question is a real holodeck close to reality? And I really want to keep this open, because I think that we don't really know where the journey is going to take us. But if you take a look at just the last couple of years, and then remember Indiana Jones rendered in 28 pixels in the 70s. If you just go back 15 years, this is what GTA 3 looked like, how a car was rendered back then. And in 2017, we're able to render a car model with 50 million polygons running in real time in 90 frames per second. So we already made these huge steps in the last 15 years. So the question really is, what are the next 15 years going to bring? You can just extrapolate from these big steps we made in the last couple of years and then see where the journey is going. And the journey of Holodeck is a long way, but we believe at Nvidia that it's a journey that will, come on. Sorry guys. It's a journey that will happen. We're very optimistic that we can pull this off. We're working on all major parts in the VR ecosystem. So we are very optimistic that in the future we will have a system that will allow us to travel to any place in the world with people from anywhere. Thank you very much.